101, y'all. Today's episode is all about natural selection. We've learned about genetics, but how do genetics affect species physically? As organisms evolve physically, how do their genes change or how are their genes affected? So, let's start off by talking with Annie and Gershna. Annie's family has a history of white blood cell disorder that causes her white blood cells to be abnormally weaker. So, Annie, tell us about this disorder and how it affected your family.
Well, hi, Abby. I'm so happy to be here and share my story with all of you. Early on in my life, my ancestors had extremely weak white blood cells. Almost everyone carried the gene, including two of my ancestors, siblings Joe and Mo and Gershna. Mo died as a baby after catching a minor infection in 1922. Joe was exposed to influenza, and because of this, his weak white blood cells couldn't fight the illness. He tragically died at the age of 44. But after he had already passed on the gene to his 3 kids. One died in his early 30s, while the other 2 reproduced and the genes were passed down yet again, but not to all of the children. This process continued until my generation. My siblings and I are all healthy and happy. If you look at our family tree, you can see that it all starts up small and grows off quickly over time as less and less people acquire the gene.
Hey guys, I'm back and I'm here with Annie and Gershna.
Hi Science 101. I'm so happy to be back and see all of you 12 web viewers.
You may remember me from past episodes of Science 101, but today we're going to find out what happens behind the scenes of natural selection. So what really happened to the Gershna family? Why did the white blood cell disorder disappear? How are Annie and her siblings healthy? Let's dive in. During reproduction, each parent passes on a set of traits to their child. For each trait, they pass on 2 alleles that are accountable for only 1 trait. Alleles are one of the 2 or more forms of a gene that are found at the same place on a thread-like structure of the nucleic acids found in the nucleus of most living cells, carrying genetic information called a chromosome. To decide the final outcome of the trait the child receives, there are dominant alleles and recessive alleles. For example, the allele for deficient white blood cells is recessive, which means the only way an individual could have the deficient gene is by having 2 of the recessive alleles, or homozygous recessive. If the pair was heterozygous, meaning that both alleles for normal and deficient white blood cells are present, then the dominant allele in this case, the allele for normal blood cells, determines the outcome of the gene and hides the recessive allele. So, when a child's genetics are being determined, they are randomly receiving 1 allele from their mother and 1 from their father. When a population is passing on traits from generation to generation, sometimes a harmful gene, like the deficient white blood cells, will become less common. This is due to the survival of the fittest, or natural selection. To put it simply, organisms with helpful characteristics survive and reproduce, passing on their traits to their offspring. Organisms with harmful characteristics will most likely not reproduce and their traits will not be passed on. As time goes on, the harmful allele for the weak blood cells will become obsolete, and this is how you get a product like Annie with no trace of the trait.
Well guys, there you have it. As you can see in the Gershna family, the white blood cell disorder was passed on but soon disappeared. Most of the people who suffered from the disease died before they were able to reproduce. Basically, over generations, if an organism has a gene that doesn't help it survive, the gene will disappear. Go! See y'all next week on Science 101.
Natural selection is cool.
Natural selection is